Yeah, so good evening, students. Hope you all are doing well, right? So let us continue the yesterday's class. So before going to start the yesterday's class, let us have a small quick revision, right? So in yesterday's class, we have started with our first chapter, some basic concepts of chemistry, where we have learned few important points regarding our NCERT textbook introduction part. That is cisplatin and Taxol are used in the cancer therapy. That is azidothymidine AZT is used for the AIDS. Then we have studied the universe is divided into two parts, matter and energy. Later this matter we have discussed some points like atom, molecule. Based on the state, physical state and chemical state, matter is divided, right? Solid, liquid and gas. Then we have studied exactly what is the meaning of element, compound, homogeneous and heterogeneous mixture, right? Then we have started with our unit conversion, which is the shortcut code is nothing but KHDMDCM, which is nothing but kilo, hectare, decameter, deci, centi, milli, right? If we are moving in, if we are jumping in right side, we have to use the positive. If we are jumping towards a backward direction, we have to use the negative. Yesterday we are done with our some examples also, right? Then we have studied with prefix micro, nano, pico, femto, auto, zepto, and if it is in positive, mega, giga, tera, peta, exa, zeta. Okay. Once again, reminding students, better you complete the work on the same day. Okay, don't delay it. Whatever the notes I'm giving you, please complete it on the same day, or else please complete it by the next class. Okay, right. Then we have studied few important conversions, how to convert nanometer to picometer, picometer to nanometer. Okay, picometer to angstrom, angstrom to nanometer. All these conversions we are done. So these two questions were our yesterday's homework question. Let us try to solve this question. So what will be the answer? 52.9 into nanometer into angstrom divided by angstrom. So what you will get, 52.9 into nano, n for 9, n for nano, 10 to the power of minus 9 into angstrom divided by angstrom is 10 to the power of minus 10. So when we do the cancellation, so you are going to get here minus 1. This minus 1 will go above. So what you will get, 5.29 angstrom you are going to get. Hope your answer you got the same thing. Let us go with the next one. So the next one is nothing but 100 picometer into nanometer divided by nanometer. So 100 pico means 10 to the power of minus 12 into nanometer, n for 9, n for nano. So what we can write, 10 to the power of minus 9. So if we do the cancellation, what you are going to get here, minus 3 you are going to get, which is nothing but our answer is 0.1. Okay, hope everyone got the same answer. The next we have started about the energy related conversions, right? After that we have started with volume. So was the most important point. Ml, what is the other name of ml? It is nothing but cubic centimeter. Other name of liter is what? Decimeter cube. Okay, and we learn that 1 meter cube is equal to total 1000 liters. Okay, this is the point we have learned. Then we have started with the pressure. After pressure we have started with the temperature. Okay, and then at the last we have started with the mass. Okay, right, so this is what we have learned. So let us start with the today's class. So the today's concept, we start with what? Some basic terms, which is very important. Some basic terms. Okay, so in some basic terms, let us try to understand the first one. So the first basic term is nothing but relative atomic mass. Relative atomic mass. Okay, so in the shortcut we are going to call it as a RAM. Okay, so let us try to understand what is the exact meaning of relative atomic mass. Okay, so actually what happened, Anand? So what is the meaning of relative? Okay, relative means we people are with comparison. Okay, the one where whenever we are doing any comparison, then we should call it as what? Relative. Okay, for example, let us take a small example. Suppose here I'm going to take one, okay, weighing pan, right? So suppose if I'm taking one side a big watermelon, I'm going to take. Okay, this is one big watermelon, right? Now other side what I'm going to do, I'm going to add the apples. Okay, for example, I came to know that 3 apples weight is equal to 1 watermelon. Okay, so what we can say here, 1 watermelon, okay, is equal to 3 apples, Okay, now next time what I'm going to do, I'm going to remove the apples, and now what I'm going to do, I'm giving some other fruit like orange. Okay, now what happened, now what you can say, weight of 4 orange. Okay, weight of 4 orange is nothing but 1 watermelon. Okay, so now the thing is that, did I mention any weight that the apple is 1 kg or 2 kg, or else did I mention anywhere the exact weight of orange is 1 kg? Nothing, right? So here we are comparing the weight of the things by comparing with what? 1 watermelon. Okay, so what, whenever I say the weight of 3 apples is equal to 1 watermelon, the weight of 4 oranges is equal to 1 watermelon, it indicates that we are not talking about the exact weight, we are talking about the comparison weight. Okay, so this type of weight we should call it as relative. Okay, now what happened in chemistry, instead of using this watermelon, we are going to use the carbon. Okay, now the question is, ma'am, why only we are choosing carbon for the weighing the other elements? The reason behind this is, you people know carbon is a very abundant element in our earth. Wherever you go, you can find the carbon in the nature. Most of the things in our day-to-day life are made up of carbon, right? So this is the reason why we are going to take what? Carbon as the main source. Okay, I hope you people understood the meaning of relative. In this simple example, we took example as what? Watermelon. But in chemistry, instead of watermelon, we are going to take what? Carbon. And instead of apples and oranges, we are going to take the other element. So let us try to understand the formula of this, Nana. So coming to the formula, relative atomic mass is nothing but what you can write, mass of one atom of any element, whatever the element you want, you can take any element, divided by 1 by 12th into mass of one atom of C12. Okay, so now what happened in this case, let us try to talk about the next part is units, right? So actually what happens, coming to the units, above also mass, below also mass, mass get cancelled. Cancel, relative atomic mass is unitless, right? Why it is a unitless? Because numerator denominator both are mass get cancelled. Okay, so let us take few examples here. So coming to the examples, the best examples you can take, suppose if I write relative atomic mass of sodium. Okay, relative atomic mass of oxygen, relative atomic mass of nitrogen. So relative mass of atomic mass of sodium is 23, or should I call 23 grams? Okay, so the answer is 23, not the 23 grams. The reason behind this is relative atomic mass is a unitless. Okay, so whenever I ask you relative atomic mass of sodium, you have to just answer 23. Oxygen is how much? 16. Nitrogen is how much? 1. Okay, I hope you people understood the first word, relative atomic mass, right? So let us go with the second one. The second one is nothing but atomic mass unit. Atomic mass unit. In the shortcut, we'll call it as a AMU. Okay, so let us write down few important points regarding the AMU. So it has two names. Okay, so it also known as, okay, it is also known as, the first one is unified mass. Okay, so unified mass you can call, which is denoted by the letter U, and the second one you can also call it as what? Dalton. Okay, but frequently used word instead of AMU is what? Unified mass. Now the question is, what is exactly the AMU? Okay, let us try to write down here the definition of AMU. Right, mass of 1 by 12th of one atom. 1 minute. So mass of 1 1 by 12th of one atom of C12. Okay, so now the question is, what is the meaning of C12? Ma'am, why are you considering C12? Okay, so actually C12 isotope. Okay, carbon has total 3 isotope. Okay, so those isotopes are 12, 13 and 14. Out of that, 12 is the most important. Okay, don't worry, detailed discussion we are going to do here, right? If you want, still I am going to write here carbon has three isotopes. It may be C12, it may be C13, and it will be C14. Out of all, which one is the most abundant? C12 is the most abundant. Okay, for a simple example, these are nothing but what we can call it as a isotopes. Okay, suppose if you don't know the meaning of isotopes, okay, let us take the example of our capsicum. Okay, now coming to the capsicum, you people can see in the market there are different colors of capsicum. Okay, you can find green color capsicum, you can find yellow color capsicum, you can find red color capsicum. Okay, but if I ask you which one is the dominant in our market, then obviously wherever we go, maximum we are going to get green color capsicum. Okay, so that means here, but whatever the different colors, all the three are capsicums, right? In the same way, whether it is 12, 13, 14, all are carbons only. Okay, but here which one is dominant out of all capsicum? Green color. In the same way, out of 12, 13, 14, which one is the dominant? 12 is the dominant, that's why we are taking C12. Okay, so let us try to exactly understand what is the meaning of AMU. Okay, now what I'm going to do, Nana, suppose I'm going to take a sample here. Okay, so this is nothing but sample. Okay, what sample? Sample of C12. Okay, now what happened? Can the sample consist of lot of C12 atoms? All atoms are carbon only, no? What is the meaning of 12? Carbon with 12 grams. Okay, now what happened? From this I'm going to take out one atom. Okay, so now what I'm going to call, can I call it as a one atom of C12? Right, now what we are going to call it as one atom of C12. Okay, now what I'm going to do, I'm going to divide this one atom into 12 parts. Okay, so what I'm going to do, I'm going to break down the atom into 12 parts. Okay, can I call it this as a one part? Right, so this is nothing but what can I call this part as a 1 out of 12 parts, right? So now what happened, its mass. Okay, so its mass is nothing but AMU. Okay, so what is the meaning of AMU? 1 by 12th mass of C1 atom of C12. Okay, now what happened, its value is also found to be the mass for the mass value. Okay, so can I say that one piece has some value, right? And its value was found to be how much? 1.66 into 10 to the power minus 24 grams. Okay, so how much mass it was found? 1.66 into 10 to the power minus 24 grams. Okay, suppose if I ask you in terms of kg, as you people know how to convert grams to the kg, whenever you want to convert grams to the kg, multiply with 10 to the power of minus 3. So if I multiply with 10 to the power of minus 3, how much you will get? 1.66 into 10 to the power of minus 27 kg. Okay, so let us try to understand again. Right, now what happened here in this case, suppose if I take this one atom. Okay, so now what happened, experimentally by using the one atom mass. Okay, by using mass spectroscopy. Okay, now the question is, what is the meaning of mass spectroscopy? It is a device in which we can measure the mass of even very little things also, very minute particles like atoms also you can find the mass. Okay, so now what the scientists they did, they took the one atom, they took one atom from the sample and they kept in the mass spectroscope. Okay, they kept in the mass spectroscopy. Okay, when they kept in the mass spectroscopy, they found that the mass was found to be, right, so as you people know the mass is very less, right? So they have, you people got some value, right, and that value was found to be something nearest. Okay, so it was value found to be 1.9 into 10 to the power of minus 25 something they got. Okay, now what they did, they divided with the AMU, which is nothing but 12. So approximately finally about how much you will get was found to be 1.66 into 10 to the power minus 24 grams they got. Okay, so don't worry, this is the little bit. Okay, but if you get confused, then no need of remembering this. This is just an extra information for you. The only thing you have to remember is just 1.66 into 10 to the power minus 24 grams. Clear till here? Right. So now what happened here? Right. So if you want, you can take Nana, or else because this is just an extra information to you. So if you take that one atom, okay, the mass was found to be 1.9 into 10 to the power minus 23, not 24. Okay. So 23 whole divided by 12, you are going to get what? 1.66 into 10 to the power minus 24. Okay. Overall value, this is an extra information. The only value you have to remember is what? 1.66 into 10 to the power minus 24 grams. Okay, right. So therefore, finally what we can say, 1 AMU value. So 1 AMU value is 1.66 into 10 to the power minus 24 grams. Okay, and this is very, very important. In many numericals, we are going to use this value. Okay, let us go with the next one now. So coming to the next one, which is nothing, the third one. Okay, the third one is nothing but atomic mass. Okay, so what happened in chemistry? Instead of using the mass, even you can use the word weight. Okay, so that's your wish. You can use the word atomic mass, or if you want, you can use the word atomic weight. So let us try to understand the definition here. So definition is nothing but mass of one atom of element in AMU. Okay, mass of one atom of element in AMU is nothing but what? Our atomic mass. Let us take a small example here. Suppose if I am taking sodium. Okay, this time I took what? A sample of sodium. Right now what happened here? The sample of sodium is made up of what? Lot of small atoms. Okay, so from this what I'm going to do? I'm going to take out one atom. Okay, so can I call it as a one atom of sodium? Right now what happened here? So for the one atom of sodium, so whatever the mass you will have for this one atom, okay, that mass we should call it as what? Atomic mass. Okay, that mass was found to be as what? Atomic mass. So what is the meaning of atomic mass? Atomic mass is nothing but mass of only one atom of the sodium. Okay, and its value was found to be 23 AMU. Okay, so let us take few examples here. Coming to the examples, you can take for example atomic mass of sodium will be how much? 23 AMU. Okay, in the same way, if I take atomic mass of oxygen will be how much? 16 AMU. Okay, atomic mass of, okay, nitrogen will be how much? 14 AMU. I hope you people got clarity about the atomic mass, or you can even call it as a atomic weight. Okay, right. Now let us go with the next one, fourth one. Right. So coming to the fourth one is gram atomic weight. Okay, which is nothing but what? GAW. Okay, or can I use the word GAM also? Why? Why I can use the word GAM? Because in chemistry, weight, other name of weight is what? Mass. So you can use the word GAM as well as you can use the word GAW. Okay, so let us start to write down here definition. Mass of 1 mole in the bracket 6.022 into 10 to the power 23 atoms of element in grams. So very, very important. Let us try to understand here what is the meaning of gram atomic weight. Okay, let us take a small example here. Right, so coming to the example, what I'm going to do, once again I'm going to take here sodium. Okay, a sample of sodium. Now what happened? The sodium is made up of what? Lot of atoms of sodium. Okay, now what I'm going to do, from here, instead of taking one atom, I'm going to take a lot of atom. This time I'm going to take 6.022 into 10 to the power 23 atoms. Okay, these many atoms I'm going to take. Okay, now what happened here? So can I call this is nothing but, right? So now what happened here in this case? Right, so this the mass, whatever the mass you have for these many atoms, right, that mass we should call it as gram atomic weight, or if you want you can call it as a gram atomic mass. Okay, and its value was found to be 23 grams. Okay, so to know the difference between 23 AMU, 23 and 23 grams. Okay, let us take a small examples here. Gram atomic weight of sodium. Next, gram atomic weight of what we can say nitrogen. Next, gram atomic weight of oxygen. Okay, so gram atomic weight of sodium is nothing but what you can say 23 grams. Nitrogen is 14 grams. Oxygen is 16 grams. Okay, I hope you people understood the difference between relative atomic mass. Okay, atomic mass, gram atomic mass. I hope you people got the clarity between them. Right, so let us go with the next one, fifth one. So the fifth one is nothing but molecular mass. Okay, if you want, you can use the one more word which is nothing but molecular weight. Molecular mass, or even you can use the word molecular weight. Okay, so let us try to understand what is a molecular weight here or molecular mass. So write down the definition. So what will be the definition? Mass of one molecule, mass of one molecule in AMU. Mass of one molecule in AMU. Let us take a small example. Suppose here I am taking a sample of water. This is what, Nana? Water. There is a glass which consists of lot of water is there in the beaker. Okay. Now what happened here in this beaker? So from this beaker, what I'm going to do? I'm going to take out only one molecule. What I'm going to do? I'm going to take only one molecule of water. Okay, now what happened? Out of lot of water molecules, I'm going to take out one molecule and its mass, whatever the mass you have, no, that mass. So mass of that one molecule, okay, is nothing but whatever molecular mass. What is that, Anna? Molecular mass, or else even you can call it as a molecular weight. And its molecular mass value was found to me how much? 18 AMU. Okay, so if you're talking about only one molecule, then what will be its weight? 18 AMU. Okay, let us take one example. So if I ask you molecular mass, okay, so what will be the molecular mass here? The molecular mass of H2O will be how much? 18 AMU. Okay, molecular mass of CO2 will be how much? 44 AMU. Now few students will be having doubt that ma'am, how you got the 18, how you got the 44? Because if you want to learn these values, first you have to learn the masses of the first 30 elements. Okay, don't worry, after completing this topic I will make you to write the atomic weights of all the elements, with important elements. Okay, right. So moving to the next one here, molecular mass of NH3 will be how much? 17 AMU. Okay. Now let us go with the sixth one. The sixth one is nothing but gram molecular mass. So gram molecular mass. And one more word is, you can, okay, gram molecular mass, it is denoted by what? It is denoted by GMM, or even you can use GMW. What is the meaning of GMW? Gram molecular weight. So instead of using mass, even you can use the word weight. Okay, right. So let us try to understand here gram molecular weight. Let us try to write down the definition. Right. So coming to the definition is nothing but what we can write down. Mass of 1 mole in the bracket 6.022 into 10 to the power 23, okay, molecules in grams. Okay, so let us try to understand here mass of 1 mole, right? So if you take the example, for example, if I take, once again I'm going to take here in a beaker water. Okay, lot of water molecules are there inside the beaker. Now what happened? From this I'm going to take total 6.022 into 10 to the power 23 molecules of H2O. Previous case what I took only one molecule. Okay, this time I took these many 6.022. Okay, so can I say they have some mass here, right? And that mass is nothing but gram molecular weight. Okay, and its value is found to be how much? 18 grams. Okay, in the previous case we took only one molecule. Now we are taking 6.022 into 10 to the power 23 molecules. Okay, if you take one molecule, then the name is molecular mass. If you take these many molecules, then the name is nothing but gram molecular weight, or you can say gram molecular mass. Let us take for one example. Gram molecular weight of H2O will be how much? 18 grams. Gram molecular weight of NH3 is equal to how much? 17 grams. Gram molecular weight of what we can take? CO2, which is nothing but how much? 44 grams. Okay, I hope you people understood the differences between all the terms, right? Let us take one small note here. So write down the heading note. Okay, so in the note we are going to write the latest word. Okay, so instead of using the word atomic weight, okay, instead of using the word atomic weight, or instead of using the word molecular weight, okay, as you people know, we can use the word weight, or if you want you can use the word mass also. Okay, so the latest word is replaced by what? No, the latest word is nothing but actual mass. Okay, so nowadays instead of using the name atomic weight of sodium is 23 AMU, instead of using this sentence you can say actual mass of sodium is 23 AMU. Okay, in the same way, instead of using gram atomic weight and gram molecular weight, the latest word we are going to use is nothing but molar mass. Okay, know the difference between molecular mass and molar mass. Okay, so Nana, what happened? Molar mass, instead of you saying the word gram atomic weight of sodium is 23 grams, instead of using this word you can use the word molar mass of sodium is how much? 23 grams. Okay, so what is the latest word for gram atomic weight? Molar mass. What is the latest word for gram molecular weight? Molar mass. What is the latest word for molecular weight? Actual mass. Atomic weight? Actual mass. Okay, I hope you people understood. Let us go with the third point, which is like our summary. Right, coming to the summary, let us try to understand element. Okay, next relative atomic mass. Okay, next atomic mass. Okay, leave some big space, and last one is what? Gram atomic mass. Okay, so let us try to understand this part now for all the four. Right, first of all, before going to start, let us take the two elements. One is sodium, other one is oxygen. Okay, now what happened? Relative atomic mass. What is the meaning of relative atomic mass? The one which you got because of comparison. Okay, atomic mass means what, Nana? Mass of only one atom. Okay, what is gram atomic mass? Mass of 6.022 into 10 to the power 23 atoms. Okay, I hope you people got the clarity. Right, now what happened here in this case? Right, so now coming to the sodium, what is the relative atomic mass of sodium? 23. Atomic mass 23 AMU. Okay, but we know that 1 AMU value, so what we can write? Instead of writing 23 AMU, even you can write 23 into 1.66 into 10 to the power minus 24 grams. Okay, so here what you can write? Gram atomic weight is nothing but 23 grams. Okay, so know the difference between this gram and this gram. Okay, this gram is for these many atoms, whereas this gram is for one atom. Okay, so coming to the oxygen here, right? In oxygen, what is its relative atomic mass? 16. Okay, right. In the same way, what will be its atomic mass? Atomic mass is 16 AMU. Okay, but 16 AMU can also be written as 16 into 1.66 into 10 to the power minus 24 grams. Okay, and here what you can take? Here you can take 16 grams. Okay, I hope you people got the clarity between all the three terms, right? So let us try to write down some important molar masses. Okay, if you want you can take the screenshot, or you can stop the video and you can write it. Okay, Right. So let us try to understand here. Write down the next heading, molar masses. Okay, so coming to the molar masses, so the first most only the one which is important, which is frequently asked in the exam, 99% elements which are asking in the exam, only those molar masses you have to by heart. Okay, so let us try to write down hydrogen, helium, lithium, beryllium, boron. Okay, molar mass means we have to take in terms of grams. So hydrogen, how many grams you can expect? 1 gram. So many students will think that, ma'am, if we double the atomic number, then we are going to get the molar mass. Means it's not always true. Okay. So when you double the helium, what you are going to get? 4 grams. Lithium 3 plus 3, 6. But we are going to get what? 7. Beryllium 4 plus 4, 8. But the answer is what? 9 grams. Boron 5 plus 5, 10. But the answer is 11 grams. Okay. Let us go with the next one. Beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay. So carbon atomic number is 6. 6 plus 6, how much you will get? 12. So you are going to get 12 grams. Nitrogen 7, 7, 14. You will get 14 grams. Oxygen 8, 8, 16. Fluorine 9, 9, 18. But the answer is 19 grams. So that's why I say better you have to by heart this instead of taking the concept of doubling. Okay. Neon 10 plus 10, 20 grams. Okay. Let us go with the further elements. Sodium, magnesium, aluminium, silicon, phosphorus. Okay. Right. So sodium, what is the molar mass of sodium here? 23 grams. Magnesium, 24 grams. Okay. Aluminium, 27 grams. Okay. Silicon 28 grams. Phosphorus 15, 15, 30. But the answer is 31 grams. Okay. Right. So let us go with the next one. So the next one, phosphorus, sulfur, chlorine, sodium, magnesium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Okay. Right. So let us try to understand here. So coming to this one. Right. So now what happens? Sulfur is 32, chlorine 35.5 grams. Very, very important. Argon is 40 grams. Potassium 39 grams. Calcium is 40 grams. Okay. Right. Now coming to the next one, you will say that ma'am, scandium, titanium, vanadium, chromium, iron, manganese, those all are not important. Out of that series, the one which are important that we are going to write here. Okay. So after that, the most important thing is chromium, manganese, iron, copper, zinc. Okay, so whatever it is, if I ask you in your deep sleep also, you have to answer what is the molar mass of the given element. Okay, if I ask you. So what is the chromium? 52 grams, manganese 55 grams, iron 56 grams, copper 63.5, zinc 65.4 grams. Okay, Nana, why I'm saying because these are like our alphabets. Okay, when you can able to read the textbook, whenever when you are able to read, when can you read the paragraphs? Only if you know the alphabets. In the same way, when you can play with chemistry, when you can understand the chemistry, means if you know the alphabets of chemistry. And the alphabets of chemistry's first alphabet is like our molar masses. Okay, right. Moving to the next one. Next few example: bromine, iodine, next lead, silver, barium. Okay, so coming to the bromine, bromine is 18, iodine 127, lead 207, silver 108, like the way you remember in the bio 108 specialty, right? Next is 137. Okay, so these are the few important molar masses. So I'll stop the class till here. Remaining part we'll discuss in the next class. So before, if you have, when you can understand the next class means only if you are able to remember these values, Nana. So what we will do by the next class, try to complete these molar masses, then only we can complete the numericals in the next class. Okay, I hope everyone understood this concept. Thank you.